Hi, my name is Amanda Pennington, and today we're going to be talking about transformation, symmetries, and tiling. So this is going to be our Module 4, Chapter 11, and we'll go ahead and get started. Okay, so it says, what type of rigid motion did Ephraim and Devontae use? And so we see this in slow motion, these tiles. They're going to go slowly around and do a rotation. And so that is going to be a rotation of 180 degrees because by the end of it, everything is upside down or backwards to the way it was. So what they did was a 180-degree rotation. Okay? So what should Efron and Devontae's problem look like? Well, this is what it should look like. They wanted to flip it over a horizontal line. So here's our horizontal line, and here's our original picture. So when we flip it, it's going to be a mirror image. It's going to be like a reflection looking in the mirror. And so when we reflect it over the line, this is what it's going to look like. And these shapes are going to be the same distance apart on both sides from the line. So we know that that is what it's going to look like. Okay? So give us a shape of one line of symmetry but no rotation symmetry. Okay, so this is going to be a nice isosceles triangle. And we know that we can break it in half, one line of symmetry right down the middle. And there cannot be a line of symmetry right across. And so this is going to be no rotation symmetry, so it's just going to be up and down. Also, this is going to be a chord, and it's the same thing as isosceles. It is going to be straight up and down with no rotation. So there's 2A. 2B says rotation symmetry, but no reflection symmetry. Okay, so we have these shapes. And so rotation symmetries, we can rotate this figure and cut it in half. And that's going to be fine. Also, this one right here, we can rotate it, do rotation symmetry, but no reflection symmetry. And so the same with this chord, it looks like two chords put together. And this can be a rotation symmetry, but no reflection symmetry. Okay, it says one line of symmetry and rotation symmetry. And that is going to be this triangle right here. We can cut it right down the middle, and we can rotate it on its side, and it can be straight across. Okay, so is Maya correct? And so Maya put these figures together, and she thinks that they form a vertex figure. And so do they form a vertex? Yes, here's the vertex where all of them come together to meet a point. But is it a vertex figure? To be a figure, this has to be in the box, and then this part right here will not touch even. So it's just an object in the box. And so that just concludes that when it's in a box, it can be a figure, and then this won't even touch the corner of it. So this is to demonstrate why triangle QPT is congruent to triangle SPT is true. And what about the angles? So we have this line M, right? And so we're going to have this other line that's going to be P. And we got these two lines that make two triangles and our points, and then these two lines. We know that first off, when we look at this, we have this common point V in the middle. And we see these lines. These lines mean that these two lines are congruent, okay? That they're the same measurement and distance from P to S and P to Q. They're the exact same measurement. And we know that Q to T is the same as S to T. They're the exact same measurements because these lines are saying that these two lines are congruent. They're the same. So with that, we know that Q PT is going to be the same as SPT is true because these sides are congruent. And that's how we know that. And the angles, so angle QPT and SPT is the same. These angles right here are going to be the exact same measurement because these lines are congruent. The lines didn't change. Now, if the line was to change, then you would have a different measurement. But since we know that those lines are congruent, that they're going to stay the exact same place, then it's going to be at the same angles in the middle. Next, we're going to demonstrate why triangle QPV is congruent to triangle SPV is true. So again, here's our line M. Here's our P. And again, this is the same figure. Okay, so these lines are going to be all congruent, just like last time. So when we're looking, we know that we're looking at QPV. Instead of going all the way down to T, we're just stopping at B. So we know from previously that the QPV is always going to be the same triangles because this is congruent. That this is the exact same measurement apart from this line. Okay, and the angles are going to be QPV are right here. They're the same ones. So this is going to make those the same angles. Like I said, since those lines are congruent, that means that the measurement is going to be the same. The angle is. And we know this is a right angle because this is a straight line right here, up and down. And it's on that line M. And so when we do that, and they're up and down like this, they will always be a right angle. Okay, now if the line was slanted or something like that, then it wouldn't be one, but this is a right angle. So, because you were going to go QVP, and it's just going to create that 90 degree. Okay, next it says construct a regular pentagon penta. So here's our pentagon, and here's PENTA, our penta. And so what it wants us to know is it wants us to figure out the interior angles and the whole angle of this penta, and we're going to use that for the next few 5-point B, 5-point C, and 5-point D, okay, to understand that. But first we're going to break this down. So to find the interior angle, we know that we need to break it down to 360 divided by 5. And when we do that, it's going to be 72 degrees. But we need to double it, okay? And so when we double 72 or times that by 2, it's going to be 144 degrees, okay? And so, and we're going to keep that measurement in mind, okay? Keep it in mind. And we're going to move on next. So we had the pentagon with, okay, PENTA. But then we're going to add this triangle, and it's going to be PQR, okay? And so we need to find the interior angle by, again, so we're going to do 360 divided by 3 because that's how many sides it has. And that's going to give us 120, okay? And so you're like, what is that O? Okay, and I wanted to show this differently. So we have the penta, or the pentagram. We have the triangle, PQR. And in the middle is going to be the center, or the inscribed center, okay? And that's going to be point O. And what that means is right now we're going to the next one, is since we know that that point is going to be the center, is that inside this shape altogether at point 0, or the center, there is going to be an angle, okay? And so we're going to take that 144 and that 120 we got earlier, the 144 for the penta and the 120 for the triangle, and we're going to have to subtract that to find what this angle is, because it's going to be in the center of the pentagon and in the triangle. So we needed to know both of those interior angles. And so we have one, we're going to do 144 minus 120, and that's going to mean that this angle right here is going to be 24 degrees. So NOQ is going to be 24 degrees. Next, it says, what is the height of a cliff? Okay, so basically what's happening is there is a girl standing off of from a distance from a cliff, and what she's doing is she's looking through a ruler, a 2-foot ruler, and she's seeing the 2 different points. Okay, so her distance from the cliff is 1/4 of a mile. The ruler is 2 foot, and the ruler between the marks that she's seeing from the bottom of the cliff to the top is going to be 1.5 inches apart in the ruler inches. And so we're going to do this problem. So we have 2 feet over 1/2 of an inch equals 1/4 mile to the height of the cliff. And the height of the cliff is what we're looking for. Okay? So first we're going to take our 1.5 inches and divide it by 12, because we need it in a decimal form, okay? And so that's going to give us 0.125. Okay, and we're going to keep that number in mind. Next, we're going to have to change our 1/4 of a mile into feet. Okay, because we need this to match. So we're doing 1/4 of a mile. Which 1/4 of a mile of which is in feet, so it's going to be 5,280 feet. Okay, so 1/4 of that is going to be 1,320 feet. And now we're going to rearrange that equation. So we need the height of the cliff now. And so we're taking our 0.125 or the 1.5 inches, and we are going to times it by the feet that she's from it, the 1,320 feet. And we're going to divide that by 2. And when we do that, the height of the cliff is going to be 82.5, but we need to round that. So it's going to be around 83 feet is the height of the cliff. Thank you so much for watching my video. I hope that I helped you in some way. And if you need any help or comments, please put those down there, and have a very blessed day. Thank you so much.